Hello future pilots, welcome to my channel, Pranjal Joshi this side. If you ever felt radio nav complicated, don't worry, you are at the right place where you need to be. Without any further delay, we will start our today's lecture, that is lecture 1 of radio navigation. In lecture 1, we will be studying some basic concepts that will be used in whole of our radio navigation further. Starting with lecture, in radio navigation, we will be using radio waves. Now, the question arises, what is a radio wave? Answer to the question is, a radio wave is an electromagnetic wave. Now, what is an electromagnetic wave? Electromagnetic wave, as the name suggests, electro and magnetic. So, a wave that produces electric and magnetic field by propagating ahead, this is known as electromagnetic wave. Coming to this diagram, in my diagram I have shown a radio wave that is propagating in the plane of the board. And while propagating, as it is an electromagnetic wave, it produces electric and magnetic fields. So, if I represent my radio wave with the black marker, it produces electric field in the direction going up and a magnetic field in the direction coming towards you. With this, we can see that our electric and magnetic field are perpendicular to each other. Perpendicular means at an angle of 90 degree. And we can also see that electric and magnetic field are also perpendicular to the direction of propagation. With this, we can conclude that electric field and the magnetic field which are produced while propagating are perpendicular to each other, and both of these are also perpendicular to the direction of propagation of wave. So, these three can be called as mutually perpendicular to each other. Mutually perpendicular to each other. This will be the term used in or given in questions. Now, moving ahead of the direction part, we come to the speed part of a radio wave. Radio wave travels at the speed of light. Speed of light value is 3 into 10 raised to power 8 meter per second. Thus, we can say that radio waves move with a constant speed, that is the speed of light. Now, these two things you might be knowing from your previous classes. So, what are the new points here? My first new point will be plane of polarization. Now, plane of polarization term will be used in your questions, and you will be asked what is the plane of polarization of this radio wave. You just simply have to answer where the electric field will be produced of that wave. Suppose we were taking this example, and in the question you were given only the direction of propagation of radio wave and the magnetic field only. Now, using this relationship, you will figure the electric field component direction, and that will be your plane of polarization. So the trick is to answer the electric field component when you are asked about plane of polarization. Moving to the second new point that you will be learning is that a vertical transmitter, this is the way of writing transmitter. A vertical transmitter should have a dash receiver. Now, I leave a dash because I want to ask this question to you. By a common sense, what will be the answer to this question? A vertical transmitter should have a vertical receiver or a horizontal receiver. The answer is a vertical transmitter should have a vertical receiver, because if a vertical receiver is there, then a vertical transmitted light or radio wave could be detected. But if this becomes a horizontal receiver, then the light that is propagating vertically gets undetected or some part of it gets detected. Now moving ahead, as we all know, all electromagnetic waves are transverse in nature. Now what do you mean by a transverse wave? In a transverse wave, particles of the medium vibrates perpendicular to the direction of wave propagation. Like in this, we were drawing a wave going in the plane of the board, that is represented by a x-axis. But let me tell you, this is the main direction of our wave. If we see the particles of the medium it is going through, it will oscillate or move perpendicular to the direction of wave propagation. After the definition of transverse wave, we move ahead to the basic properties related to transverse wave. Our first property we will be learning is the amplitude of the wave. Amplitude is represented with a capital A, and it is the maximum displacement of a particle from its mean position, which is measured perpendicularly. Listen to the definition again with the help of diagram. It is the maximum displacement. The particles are vibrating here also, but maximum at one point, which is known as crest of the wave. Maximum displacement of a particle from its mean position, which is measured perpendicularly. I hope you are clear with this definition. Moving ahead to definition number 2, that is wavelength. Wavelength is represented with the symbol lambda. And what's the definition of wavelength? It is the distance between two consecutive points vibrating in the same phase. What do you mean by vibrating in the same phase? That is from one crest to another crest, or from one trough to another trough. It can also be defined as length of one cycle in meters. How do we define a cycle? Cycle is a repeating unit. So from this point to this point, you can see it's one complete cycle, and it will repeat again and again to form a wave. In meters is written with red pen because the SI unit of wavelength is meters. Moving ahead to the third definition, that is frequency, symbolized as nu. In wavelength we said it is the length of one cycle in meters. Frequency definition is number of cycles in 1 second. If we take a 1 second time frame, how much cycle is produced in a wave? That is frequency. Don't mix these two definitions. SI unit of frequency is hertz or per second, and SI unit of wavelength was meters. Now we will see a formula which relates frequency with wavelength. Frequency with wavelength is represented by the formula C is equal to mu into lambda. C is equal to mu into lambda, where C stands for speed of light in meter per second, mu stands for frequency, SI unit per second, and lambda stands for wavelength, SI unit meters. Why we have written this formula that we did in our earlier classes too? It is written to decode the relationship between frequency and lambda, which is inversely proportional. If our C, which is speed of light, is constant, that is 3 into 10⁸ meter per second, and we took lambda to the left hand side of the equation, we can deduce that nu, frequency, is inversely proportional to lambda, which means if lambda is more or range is more, then frequency used should be less. This is the concept used in propagation part, or in fact whole of the radio navigation ahead. With this we come to the last star point, that says A hertz. What is the definition of a hertz? This is a very standard question. You can find it in any book. You will be following for doing questions, and we will be making a question series separate also. So a hertz means a cycle per second. Remember the statement, and I will also define it to you. A hertz. Hertz is the SI unit of frequency. A here means 1 hertz. 1 hertz. 1 hertz means a cycle. One cycle. 1 hertz means 1 cycle. Per second also means in 1 second. 1 hertz means 1 cycle in 1 second. If the time frame from this point to this point where one complete cycle was there is 1 second, then it is known as 1 hertz. I hope you are clear with this. Just remember this point on your tips. Now we will see unit conversions table that will be used in numericals related to navigation. We will be remembering naming from 10 raised to power 9 to 10 raised to power minus 9. I have written this table for meter. You can convert any SI unit with the following. Starting with giga, which is 10 raised to power 9 meters. Then comes mega, 10 raised to power 6, kilo, 10 raised to power 3, dec A, 10 raised to power 1, dec C, 10 raised to power minus 1, centi, 10 raised to power minus 2, milli, 10 raised to power minus 3, micro written with this symbol, 10 raised to power minus 6, and nano, 10 raised to power minus 9. Now, how we will convert the units? If we want to go from greater unit to any lower unit, we will multiply it with the 10 raised to power x term. And if we want to go from lower unit to greater unit, we will divide it with the 10 raised to power x. 10 raised to power x is depending upon you have to convert gigameters to meter or gigameters to decimeter. That's based on the question. Now, how you will remember when we have to multiply 10 raised to the power x or divide 10 raised to the power x? For this, I have written the short trick we used in unit and dimensions chapter, which says that our number is inversely proportional to unit. So, if you are decreasing the unit, you need to increase the number. And how you will increase the number? By multiplying it. And vice versa, if you are increasing the unit, you need to reduce the number. How you will reduce any number? You will divide it with the 10 raised to power x factor. Now we will be moving to the most asked question when it comes to radio basics. So whichever instrument we will be doing further in radio navigation, we will be looking upon its frequency band that it operates in. Starting with our table, we will first learn the naming of a frequency band, then coming to frequency that the band contains, and lastly wavelength. So the naming of frequency band goes like very low frequency, then low frequency, MF stands for medium frequency, HF high frequency, VHF very high frequency. Till now you can write it very easily. Very low, low, medium, high, very high frequency. After this, we are left with three terms that are stated as UHF, ultra high frequency, SHF, super high frequency, and EHF, extra high frequency. For writing the naming of this from VLF to VHF, it is very easy to write. VLF, very low, LF, MF, HF, VHF. For writing UHF to EHF, we can use a short trick, and that is the word use. U-S-E, which is the first letter of our frequency band, where U stands for ultra high frequency, S stands for super high frequency and E stands for extra high frequency band. Now, moving on to the frequency that these bands contain. I will start speaking the frequency it contains and you will see that there is a series to write this. VLF contains 3 to 30 kilohertz. Remember, kilo is 10 raised to power 3 hertz. LF contains 30 to 300 kilohertz. MF 300 to 3000 kilohertz. Then HF contains 3 to 30 megahertz. VHF contains 30 to 300 megahertz. Mega is for 10 raised to power 6 hertz. UHF contains 300 to 3000 megahertz. SHF contains 3 to 30 gigahertz and EHF contains 30 to 300 gigahertz. So you might have observed that a series of 3 to 30, 30 to 300 and 300 to 3000 is followed with unit starting from kilohertz, moving ahead megahertz and lastly gigahertz, because kilo is 10 raised to power 3 hertz, mega is 10 raised to power 6 hertz and giga is 10 raised to power 9 hertz. We change the series after the term 3000 comes, because if we have to write this 3000 kilohertz, 3000 kilohertz. Now, kilo can be defined as 10 raised to power 3 hertz. And if it is 10 raised to power 3 hertz and it also contains 3 zeros in it, then it becomes 3 raised to power 3 into 10 raised to power 6 hertz, or which you can write as 3 megahertz. And also this term 3000 megahertz, mega stand for 10 raised to power 6, so it will be converted to 3 gigahertz. Hope you are clear with this. Now coming back to wavelength part of our frequency bands. Wavelength can be calculated on paper by the formula C is equal to nu into lambda, which we did previously, where C stands for speed of light, nu is the frequency and lambda will be our wavelength. But if someone directly asks you, you can't do that calculation in your mind. So for that, I will tell you a trick to remember. For VLF band, you have to remember the word that wavelength is metric. You only have to remember this. After this, we have a short trick that goes by K. King Henry died. Kilometer, hectometer, decameter. King Henry died. Mother didn't cry much. You might have done this trick earlier in your classes, but you can write from LF to EHF and the frequency gets converted into the wavelength directly in your mind. Moving on to the last topic of our today's lecture, that is attenuation. Now, what do you mean by attenuation? Attenuation is reduction, or we can say decrease in signal strength. Decrease in signal strength with increasing distance from transmitter. This you can see in your house also. The place or the room where Wi-Fi router is placed, Wi-Fi signal is the strongest there, and as you move away from the place, the signal decreases. Now, there are 3 reasons for attenuation to occur. We will do reason one by one. Starting with our first reason, that says small electric current is produced in medium through which our waves travel. Small electric current is produced when our waves travel through any medium. This you can look or visualize by losing of electron as our wave travels further and further, and these electrons are referred as small electric current. Moving on to second reason why attenuation occurs is radio waves expands I have drawn this diagram showing the radio wave expands as it goes away from transmitter. Radio waves expands as it goes away from transmitter. Third reason why attenuation occurs is, or the relation between frequency and attenuation is that these both are directly proportional. It means if frequency is high, it will be attenuated more, or the decrease in frequency will be more. Now, how you will remember this statement? Remember, I told you nu is inversely proportional to lambda, where nu is the frequency and lambda can be represented for the range. Now, if we see, we are increasing the frequency in an example. If we increase the frequency, the lambda or the range decreases. Now, why the range decreased? Because the attenuation increased. So, by this relation, you can remember this, that if frequency increases, attenuation also increases. Thus, it travels less. With that, we move to the last point of our today's lecture, that is, range of a vertically polarized transmitter is more than a horizontally polarized transmitter. I will give an example for supporting this statement. Suppose I am a transmitter and I am transmitting waves toward you and you are my receiver. Firstly, I transmitted a vertical wave towards you. In visualizing this in the real world, you will see that I have to go through less objects in order to reach my receiver. And if I have to go through less objects, my energy remains conserved, or the energy lost is less, and thus I can travel more. But in the opposite side, if I transmitted a wave horizontally towards my receiver, then visualizing this, I have to go through more objects to reach my receiver. If I have to go through more objects, I will be losing my energy more, and thus I will travel less than a vertically polarized transmitted wave. With this, we are done with our today's lecture about radio basics. Now we will be moving ahead to radio wave propagation. Hope you understand each and every point of my lecture very well. In case you are having any doubt, feel free to ask. Bye bye. See you soon in the next lecture.